In this presentation, we'll continue to solve absolute value equations, but this time we'll make them a little bit more complicated. So for example, we'll be solving an absolute value equation, absolute value of x plus 3 equals 10. Again, it's important that we think about this as the distance. The distance from this thing to 0 is 10. So that means that whatever is inside that absolute value bars, in this case, x plus 3, must be 10 places away from 0. In other words, x plus 3 has to be 10 places to the right of 0, or x plus 3 has to be 10 places to the left of 0. So if you look at the problem, there's two bars. It's almost like one of those bars, or each of those bars, guide us to a different equation. So now that we're here, we solve each one, and we get x equals positive 7, and then we get x equals negative 13. So there are two values that if I take 7 and plug it into x plus 3, I get the absolute value of 10, which is 10 away from 0. If I take negative 13 and plug it in for x, I get the absolute value of negative 10, which is also 10 away from 0. So then trying that again, we're looking for the absolute value, or the distance away from this piece to 0 to be 22. So that means that either 3x minus 4 is to the right of 0, being at 22, or 3x minus 4 is to the left of 0, being at negative 22. Notice that as soon as I've split the equation up into two other equations, I've gotten rid of my absolute value bars. So I add 4 in both of them. 3x equals 26, and 3x equals negative 18. I divide by 3, x equals 26 all over 3, x equals negative 6. Those are my two solutions. Notice that these solutions really don't look like they have anything in common. It's not like the past absolute value problems where we've had two solutions, one positive and one being negative. And the reason being is that I'm doing so much to that x inside the absolute value. I'm multiplying it by 3 and I'm subtracting 4. So that's going to give me two very different values. So how about when we have an absolute value with some operation after it? Well, we still have to make sure that we solve for our absolute value first. We isolate our absolute value. So I'm going to subtract 9 from both sides, and I'm going to get the absolute value equals negative 7. So then we would split it up into two different equations. Well, if you thought that, then you may have been fooled. We should be alarmed about that negative distance again. Just like before, I should never have an absolute value equaling a negative number. That refers to negative distance. That means that this problem still cannot be found. This still has no solution, as absolute value can never equal a negative number.